Hi, my name is Zach Fisher, and welcome to another Tech Talk. And this one is going to be an extension of the DCV study session that I've got going on here. So today I will be talking about networking and some virtual networking questions that are going to come up on your VCP to study for, basically concepts to study for. So to begin with, you have to understand what is the difference between what are a few of the biggest concepts to understand. And in virtual networking, what you have to understand is what is the difference between a standard switch, a distributed switch, port groups, and just ports or VM kernel ports. So it's mainly a matter of organization as well as a matter of enabling some of the advanced features like VLANs and traffic shaping and IO control and multicasting and TCP/IP stack vMotion. But having a distributed switch is going to give you more functionality. That's the bottom line. Is that if you have a distributed switch, it'll give you easier management and more functionality. So it's basically putting all of your virtual switches. So when you make a VM, you automatically tie it to a virtual switch. A standard switch. You make a standard switch, and that basically enables the VM to talk to other VMs just like normal switches do. And then every VM, you're going to have a standard switch associated with it. But what you don't want is 1,000 standard switches to manage. So that's why they came up with this concept of distributed switch, where you can standardize some of your settings and manage all of those switches together as one. Same thing with port groups. So when you create a VM, you put in a VM kernel port that's associated with it. And each VM is going to have at least one of those. And to enable easier access, easier control, and essentially you're going to eventually be able to control better performance, they put in this concept of port groups. So the port groups is kind of that dotted line around the ports, and the distributed switch is the dotted line around the switch. Whereas a standard switch would just be a single VM would have a standard switch, and a single port would be a port, right? So things that you need to remember are some of the things that distributed switches do for you. So if you think about having a private VLAN, so that's a private versus private, and then a VLAN, you can't have a private VLAN on a single VM. That doesn't make sense because it's not a full network. So to have a private VLAN, you have to have distributed switches. It makes sense that you would have to have it. So some of these things make sense if you just think through them. So traffic shaping. So if you have a large amount of traffic going through multiple VMs, you have to have multiple switches to enable traffic shaping. IO control, I got somebody going in, somebody going out. IO control, same thing. You're not going to be able to control one switch to one VM. That doesn't make any sense to control IO unless you have multiple. And then multicast snooping, being able to look and see multiple switches, that's pretty obvious as well. And then TCP/IP stacked vMotion, being able to vMotion multiple VMs across networks, that makes sense. Like, you're gonna have to have a distributed switch for all of those things. So a lot of the functionality can be achieved through standard switches, but much of the advanced functionality needs distributed switches. Now we're going to go into, there's a couple of things to note. So there's more questions, it seems like, on setting up vCenter HA than a lot of different topics. So it is important to understand how you're going to set up your vCenter HA network. And one of the, there's basically some best practices that you need to accommodate, and some of these, the vCenter HA will not work if you don't buy them. So if you think about it, you've got several vCenters, 3. You've got the active, you've got the passive, and you've got the witness, which means that you have at least 3 physical hosts, and you want to be able to constantly see those hosts. So assigning a static IP address makes it easier for your host to know exactly where they are, and so the witness can maintain quorum, which is the important thing for the witness to do. It makes sense that you would have to put static IP addresses there. So the next important thing is that the management network cannot be on the same subnet as the HA network, the vCenter HA network. And that is just to make sure that there's no contention going on. You want to have a specific network set up for HA, for vCenter HA. So there's a specific HA network that we set up for vCenter HA, and that's important to know and to remember. And another important thing to know, and this is pretty common throughout networking, so if there's a question regarding what is the max latency that the network can sustain, it's always going to be 10 milliseconds. That's why I've got a I don't know if you can see that or not, but it says takeoff in 10. So it's like I like to think of liftoff in 10, 9, 8, 7, 6, that type of thing. And then not having a gateway, that's important, default gateway in the network. So the reason for that is simply that you don't want people getting in and out of the network and talking to you. You want IPv4 or IPv6, but not both. And you want to make sure that your active node is actually already deployed. So it makes sense. You don't want IPv4 and IPv6. It's ludicrous. Why would you, why would you do that? You do either or. That's what makes sense. So those are the important things about the vCenter HA network. Not to be confused, and this was going through my mind a lot. When they say HA network, they don't necessarily mean the vCenter HA network. So the HA network for specifically VMs maintaining high availability, that it uses the management network or the vSAN network. So that's important. So there's stipulations regarding, the HA network is going to be on a different network than the vCenter HA network, and it will be on it will be using the management network, or if you have vSAN enabled, it's the same thing as the vSAN network. So it will use the vSAN network. It's renamed the vSAN network. So that's the important thing to note, which makes sense because it's basically doing a lot of the same things. VMs are talking to each other and striping data in between them. So that makes sense. Now, a couple of things under this. I covered the HA network setup and kind of the differences between the HA network and the vCenter HA network. Now, if you need to start to think about the important things that they're going to be asking you are, you're always going to need to know how are you going to troubleshoot this. So VMK ping, that will ping a VM kernel port. So your port on your VM, it will ping that and tell you, do I have a response and what is the time? Another important thing to note is, how are you going to discover these ports? Well, there's a few commands. It's either CDP, which is, I think, the Cisco Discovery Protocol, or the LLDP, which is the, I'm not sure exactly what it stands for, but you don't need to know that. But those are the two ways that you can discover ports, and that is how you would ping a port. So you can discover using several different methodologies. I believe it's advertise, and there's a couple of other ones in there. So that I may cover that in another video, but right now just understand that those are the two protocols that you can use to discover your VM kernel ports that I was talking about earlier. Now we are on to the second half of this video, talking about networking. This is a beast. Networking is a pretty big subject here, but MTUs. This is an important concept to understand in vCenter networking. That MTU stands for a max transmission unit. That is, they may say MTU or they may say max transmission unit, and those are the max size that your network will allow frames to be read through. So it's in between 1,500 and 9,000 bytes. So you need to remember those two numbers. You need to remember that the MTU needs to be enabled all the way across the board, from the storage array to the switch that it goes across, to the V switch, to the standard V switch, to the distributed V switch, to the VM kernel port, to the actual VM. At any point that it is not enabled, it will throw errors or cause issues. So make sure that you know that to allow jumbo frames, which are large frames, you need to enable it everywhere. Now, why would you use a jumbo frame, which has a large MTU between 1,500 and 9,000? Why would you use a large jumbo frame? The answer to that is that you would use it to increase performance. So if you're sending less amounts of packets, you may actually increase your performance. Like your CPU performance may actually increase if you're doing that. So make sure that you do that. And there's one more piece that I missed here when I was just kind of spitballing, is that you need to make sure that the VMX network adapter is what you have for jumbo frames, and that is jumbo frames are enabled. Now, there's 3 different types of iSCSI that jumbo frames are supported on, and that's software iSCSI, iSCSI, and hardware iSCSI. So those are the important things to know about jumbo frames. Let's move on here to network auto deploy. So there is this concept that I don't think I've covered quite yet, and I may do a specific video on it, and it's called auto deploy. And auto deploy is a pretty sweet thing, because what auto deploy does is auto deploy automatically deploys your VMs with specific settings. That's awesome. That saves you a lot of time. But things can get complicated in the network, so you need to make sure you abide by the best practices when you're using auto deploy. And what are those best practices? Well, when you initially use auto deploy, you need to use IPv4. Later, you can convert it to IPv6. To give out your network addresses, you use your DHCP reservation, for your DHCP server for reservations. And then the third thing that's important is that using auto deploy, they recommend that you don't use VLANs. Now, you can use VLANs. You just need to make sure that your VLAN can reach your DHCP server, but they don't actually recommend to use VLANs. So those are the important things. When you're doing auto deploy, you need to remember IPv4, use DHCP reservations, and don't use private VLANs unless you have access to the DHCP server that can give out your addresses, your IP addresses. So, DRS, now down to distributed reset source scheduler. This is now network aware. So it will distribute resources based on if there's a network bottleneck, it will not move a VM to improve its performance. This makes sense. I think that happened in VSPHERE 6.5 to double check that. But that's important to know. What is DRS? What is auto deploy? What they're to use? Now we're down to network I/O control, or NOIC. And they will call it NOIC, which is weird. I think I saw it in the practice test, NOIC. And I was like, what the hell is NOIC? Network I/O control. And you'll see that as you look through the VMware knowledge base documentation, and that's probably why they put it in there, to make sure that you're looking through that. What does it do? It increases your performance. How does it do that? Well, your network performance, well, it's going to segregate some of your traffic into pools. This is how it's going to do it in the back end. You have your fault tolerant, your iSCSI, your vMotion, your management, your VSPHERE application, your NFS, and your VM pools. And then, you know what you can do? Have you ever heard of reservations, shares, and limits before? Sounds eerily similar to the way that CPU is done and the way that memory allocation is done. Well, it is. Same thing. Reservations is the minimum amount that of network bandwidth that you're going to get. Shares is a percent or a ratio of network I/O that you're going to get. And limits is the absolute most I/O that your VM is going to get. There you go. Pools. So shares, reservations, limits. Then you need to know that V3 is the current NOIC, or network I/O control version that you're on. And upgrading to V3, you have to understand that it's going to be non-disruptive, and it's going to automatically upgrade to V3 when you migrate. And if you don't that's only if you don't use, there's a couple of legacy features that are not on V3 but are on V2. And if you do that, if you use those, then it will be disruptive. So keep that in mind. And V3 is better than V2. It allows you to have separate models for fault tolerance, for VMs. For some of these things, there's separate pools for those that were not in V2 that are in V3. So network I/O control is much enhanced from V2 to V3. Overall, remember that they're going to quiz you on these specifics, so you need to know all of these little details that I've gone over. They're not, you do need to understand the concepts. That's a prerequisite to understanding the specifics. And a lot of the specifics, they make sense. You just need to think about them for a second. There's a reason why VMware designed vSphere the way it did. So I hope that this helped everyone understand networking and within VMware, within vSphere, and it gave everyone a little bit of a leg up on the exam, on the DCV exam for 6.5. Thank you everyone for listening, and be sure to like, comment, and subscribe. Thanks.